Okay, today we're going to take a look at investigation 3.1 from comparing bits and pieces. Our focus today would be how we can use the number line to help us think about fractions that are greater than or less, greater than 1 or less than 0. And how we do this is by realizing that there are two sides to our number line. There is the right side that we spend most of our time in, and those are our positive numbers. And then we have to the left side of 0, which are negative numbers. And the whole series of positive and negative numbers is referred to as, those numbers are called integers. Okay, fancy name, integers, that just means every positive or negative number. So let's take a look here. We're going to go down. And we are talking basically about just extending our number line. So in investigation 1, we worked with numbers, fractions that were between 0 and 1, parts of a whole type of stuff. Today and on Monday, we are going to work on numbers that are bigger than 1, but still in between parts of wholes and that kind of thing, and less than 0, so that we'd have integers. So whole numbers on a number line flow one another in a simple regular pattern. Between every pair of whole numbers, there are many other points that can be labeled with fractions. The number such as 1 1/2 is called a mixed number because it is a whole number and then a fraction part. Another way to write this is as an improper fraction. For positive numbers, an improper fraction, such as 3/2, has a numerator greater than or equal to the denominator. So, what this really means is that even between 0 and 1, so like if this was, let's change these. What if this was 1 and this was 2? We can actually cut this number line into an infinite number of pieces. Each half can be divided in half. Each fourth can be divided into fourths, so on and so forth. So just like the number line goes on forever in both directions, okay, we have a positive infinity over here, and we have negative infinity on the other side. They're both infinite sides. We also have an infinite amount of possibilities that come between our numbers. We have an infinite number of parts of a whole. But it kind of depends on what our task is and that kind of thing to decide. So let's take a real quick look at this question. It says, why can this point be labeled with two names, 1 1/2 and 3/2? And the answer is because if we cut the number line into halves, okay, so I'm going to go from 0 to half. That's 1. Half to 1. There's 2. And then 1 to 1 1/2, there are 1, 2, 3 halves. Okay, the other way of looking at it is that we have the whole number 1. We're going at least 1. So we have a distance that is a whole number of 1. And we are going halfway to our second whole number. So that would be 1 1/2. Now, we can convert between the two. Okay, for example, we talked about fractions being nothing more than an addition or a division problem. So if we take our numerator and we divide it by our denominator, so that really means numerator divided by the denominator. So if we take 3 and we divide it by 2, we're going to have one whole, okay, and that leaves us with a remainder of 1. And then what we do here to make it into a fraction is we take our remainder, which is our whole number, or not our whole number, our numerator, and we are going to put it over our divisor, which is going to be our denominator. Okay, so that's one way. The other way that we can keep solving this is by returning it back to its original form right here, and then we could add a decimal and a 0 and bring down the 0, bring up our decimal, and then 2 can go into 10 5 times. We are left with 1 1/2. Okay, and 1 1/2 as a decimal looks like this. 1.5 as a fraction looks like that. And so it's really the same, two ways of writing the same number. Now, this brings us into this whole improper fraction thing. I know in middle or elementary school they might have told you that improper fractions, you're supposed to write them as mixed numbers and blah, blah, blah. There is no such thing as an improper fraction. The reason why they're actually called improper fraction is because the numerator is greater than the denominator or equal to. We typically think of a fraction as part of a whole and therefore smaller, a small piece of something larger. And because of that, if we are showing fractions that are bigger than 1, in fraction form, we call them an improper fraction because we're referring to more than one part of one whole. So that's, I know it's a little confusing, but it does work, and with some practice, it becomes way easy. So let's go on here. So like if we have this number line here, we have, like I was talking about earlier, we can extend that number line forever in both directions. And to the left, these are negative, and it's basically a mirror image. It'd be like if we used 0 as our line of symmetry on the number line, then 1 and -1 are what we call opposites. Okay, they're opposite of each other. They're the same distance away from 0, and they are opposites. So let's take a look at a few problems. Okay, the first one says, Betty says that there is a mark, but that the mark between 2 and 3 should be labeled half. Do we agree? So she's saying that this mark is equal to a half. Well, Betty is partially correct in that it is halfway to 3, but it is not only worth 1/2. It is actually worth, okay, if we count it up, 1, 2, 3, 4, 5 halves. Okay, or going with whole numbers, it's 1, 2 wholes, and then half of another one. So 2.5. Okay, so Betty's mark is okay in the fact that she's realizing that it's halfway between 2 and 3, but the actual proper label for that number should be 2.5. Okay. Judy also says that the mark between 2 and 3 should be labeled as 5 halves. Do you agree? Well, Judy is correct because she's counting up the number of halves that we have there. So there's 1, 2, 3, 4, 5 halves in 2.5. All right, so we could also write that because they're equal. Okay, these are both equivalent. Whoops. Okay, so let's go on to the next one. What label would you put on the mark between -2 and -3? Well, this one is pretty simple. If we would put 2.5 on the line between 2 and 3 on the positive side, then over here on the negative side, we should put this as -2.5. Okay, so it's the mirror image, only it's negative. Again, they are opposites. Opposite meaning that they're the same distance from 0, but they're on the opposite end of the world from each other. All right, so if there were a mark halfway between that mark and -2, what label would you put on it? So what they're asking us on this one is if we had a mark right here, halfway between -2.5 and -2. Well, normally when we move to the right, we're getting larger, but because we're in the negative values, our number is actually going to be smaller. So a mark right here would be -2 because we are 2 wholes away, but then we only are going 1/2 of 1/2, and 1/2 of 1/2 would be 1/2 times 1/2, which equals 1/4. So because we have 1/4 of that distance and we are on the negative side, then our fractional label for this mark right here is -2 and 1/4. And now my pen quit working, so we're going to go with -2 and 1/4 with the mouse, and it's not going to work either. All right, so continuing on. All right, so let's scroll down the page even further. And then it's talking again, here's the definition of opposites. It's simply meaning that they are the same distance from 0, but in the opposite direction. They also, opposite numbers, will have the same absolute value, which means if we counted up their distance from 0, that would be their absolute value. It's like what the number is worth, but right next to 0. So if we come over here and we start at 0, 2.5 would be 1, 2, 3, 4, 5 halves away from 0. But if we go in the opposite direction to the negative side, it's still 1, 2, 3, 4, 5 halves there too. So just because it's negative doesn't mean that it doesn't have the same absolute value. All right, moving on. And here is the concept of absolute value, real quickly. This concept of absolute value. The first thing that we're going to point out is that a number and its opposite have the same absolute value. And when we are writing absolute value, we use these bars to the side of the number. So that if we were to talk about the absolute value of a -4, that answer is 4. Absolute value is neither positive or negative because we are only counting distance from 0. So we use the bars off to the side to indicate that the absolute value would be 4. Sometimes on the calculator it'll put in this ABS and then use parentheses around it. But mainly, anytime that you see the bars, I want you to know that that means absolute value. So if I ask what the absolute value of 5 is, that's the distance from 0. So how far is 5 away from 0? The answer to that question is 5. What about the absolute value of -27 1/3? Okay, well, how far away from 0 would -27 1/3 be? You would be on the negative side of the number line, but we're still only counting distance, and therefore the absolute value would be 27 1/3. All right, so real quickly before I let you go, you are going to need to take a look at question A1 before coming to class. So we're going to go over here and I'll show you A1. All you're going to do is make a number line and then label these fractions on that number line. Of course, the ones with the negative sign should go to the left of 0. The ones without are positive and should go to the right of 0. So there you go. That's the lesson, and have a good night.